All right, today we're proving things about rectangles and kites. So we'll start off with our rectangle. The definition of a rectangle is basically this picture, and that is that we have 4 congruent right angles. There are lots of other things that you know about rectangles, and you're right, they're true, but they are theorems that we're going to prove, not the definition. So we're starting off with our our definition, and we are going to first of all prove that it's a parallelogram. The reason we want to do that is if we can prove that it's a parallelogram, then all the facts that we know about a parallelogram will also be true about a rectangle, which would be fantastic. So what we need to do is to start off with our given. We have to use our, oh, my brain's not working. We have to use our definition. So we have to say that angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degrees. I want to say all of them just in case I need to know that they're not just equal to each other, but that they're 90. I'll put it all in one so I don't have to come back to it. Now, I'm trying to get this parallelogram. The way that I prove that it's a parallelogram is to prove that the sides are parallel, and the only way to prove parallel is through angles when we're talking about these guys here. And in this case here, I don't have alternate interior, and I don't have corresponding, but what I do have is same side interior. So I don't want to add in extra lines here because I have same side interior. So I'm going to use these guys here specifically, that if these guys are both equal to each other and 90 degrees, that would tell me that AD is parallel to BC. So let me draw that out. If these guys are equal to each other, that would mean that those guys are parallel. And the reason would be same side interior angles are supplementary, give us parallel lines. And I'm going to use these guys, again, not just that they're equal, but they're also equal to 90, that's key because they're supplementary, is, I'll go ahead and draw that. If I have, no, I don't want 70, that's not going to be helpful. Oh my god, let me erase that. I need another set. I need these guys, so I need like B and C. So those overlapping dudes are going to give me AB is parallel to DC. And our reason will be, again, same side interior angles are supplementary, give us parallel lines. So we take a step back and we've just proven that these are parallel and that these are parallel, which means that we have a parallelogram. Why does that mean we have a parallelogram? Because of the definition. The definition says that we have 2 sets of parallel sides. So we have to think about, what do we know about a parallelogram? We know that the opposite angles are equal to each other. Well, that's not really anything new. We already knew that. We know that the opposite sides are congruent to each other. That's new. We knew that from experience, but we had to prove that. And we also know that the diagonals bisect each other. So now we know 2 more things about a rectangle because we know that it is a parallelogram. So we're going to switch gears here and look at a kite. So for a kite, if I go back to my original little triangle situation here, and if instead of rotating it to get a parallelogram, if I had reflected it, I would have gotten a kite. So what that tells me is there's a lot of things that I should know about this kite. I should know that these angles are equal to each other. I should know that this side is equal to that side. I should know that these angles here are equal and these angles here are equal. Let's mark them differently. I know a lot of things. So let's go ahead and see what we can prove. Given that it's a kite, we need the definition of kite. The definition of kite is 2 sets of consecutive congruent sides. And we want to prove that one set of opposite angles are equal to each other, and that when I cut this in half, these angles here and these angles here are equal to each other. Which means I want to prove a whole lot of angles, which means I probably can't use that as the starting part of my proof, but I can use my given. So the kite says that AB is equal to BC and that AD is equal to DC. Those are my consecutive, one right after another, consecutive, one right after another sides. And so that is the definition of a kite. Now, again, I wanted to prove that the diagonal bisected the interior angle, so I need to draw an auxiliary line. So we're going to draw BD auxiliary. Again, all I did is connect two dots. That's all I really did on that one. So now I can say that, bring it up here. BD equals BD, right? And look at my triangle. I have proven the two triangles are congruent to each other. So ABD and CBD. So, I'm almost there. I wanted to prove that one set of opposite angles are equal, so I'm going to have A and C. Why? Because my triangles are congruent, so all the little parts are too. Which tells me one set of opposite angles are congruent, and I'm using the definition of opposite to do that, because these are opposite, and that is what that tells me. So I've got this guy here. And then I'm going to put some 1s and 2s and 3s and 4s in here. I could say angle 1 equals angle 2 and angle 3 equals angle 4. Why? Coming from the triangles, if my triangles are congruent, then all those little parts are. Which tells me that one diagonal bisects the interior angles, and that is the definition of bisect and interior angles. So, there you have it. We've gotten two new proofs now about a kite. Now, we're going to put all of this stuff together here. I'm going to use both the definition as well as these theorems here to do this. And what I want to do is I want to prove that one diagonal bisects the other. If that's what I'm trying to do, I really need to have both diagonals in here. So I'm going to draw in both diagonals. So I'm going to draw, what is it, BD and AC and label E. So we'll do E here. Now, auxiliary lines. We need to start with a kite. Whew. All right, so I need to figure out what I need to prove congruent here. I do have some options. I want to prove that this is equal to this, which means that I need to either show that these two triangles are congruent to each other, or I need to show that those two triangles are congruent to each other down there. For whatever reason, I just like the little ones, so we're going to go ahead and stick with the little ones. So I want to prove that those two triangles are congruent to each other. So with those triangles, and let's just make sure. So if that was true, if these two triangles are congruent, then these two parts would be equal, and these would be equal and supplementary, which would make them 90 degrees. Those two combination of ideas, equal and supplementary. So let's see if we can do that. If I want to prove that this is congruent, the definition says these guys. Now, up here I used all four. I don't want all four. I only want these two. Whoops, let me do given and then definition of kite. And let's see what else I have. I also obviously have reflexive. And I know I can't get those yet because that's what I'm trying to prove, so I'm not going to be able to do that. But I haven't used anything up here yet. So the one diagonal bisects the interior angles means I've got these guys right here. So I'm going to put numbers in here, 1 and 2 again. So I can say Angle 1 equals angle 2, and that is theorem. Diag bisects the interior angles. I would love to say that we don't need to actually state the theorem, but we do. There's lots of theorems, so we need to be specific about which ones they actually are. Alright, so we look at what I have here. I have enough. I have SAS. So, I've got two things that I'm trying to prove. I'm going to prove that one diagonal bisects the other diagonal. So in other words, I want to prove that this is equal to this. And I am so there. I know that those parts are equal because congruent triangle is giving congruent parts. And I chose those parts because those are halves of the diagonal. So diagonal bisects other diag. And that would be definition of diag and bisect. So that's one part, check. I also need to do perpendicular, which, before you listen to the rest, I would challenge you to go back and look at this. It's identical at this point. We're trying to prove congruency, trying to prove perpendicular. It's always the same way of proving perpendicular. You've already done it on this problem here. So give it a shot before you kind of continue with this one. I'll go ahead and tell you. The only thing you can get from congruent triangles is congruent parts, and the parts that we have, we'll go ahead and put a 3 and a 4 here. Now, I know that those are equal to each other, but not only are they equal to each other, they are linear angles, and linear angles are supplementary. Since they are equal and supplementary, if I combine those two facts, that gives me that they are both 90 by using substitution. Do a little algebra there. And if they are both 90, then that means that AC is perpendicular to BD. Definition of perpendicular. And the reason I chose those is so that I can say the diags are perpendicular, and so that would be the definition of diagonal.